could, okay? I just wanted to make sure that everybody sees like this right here, to make sure that it's obvious to go from this to this form right here, okay? And this is on that special summations worksheet that I gave out last time, okay? You should have that, but if you don't have some copy, okay.
Chris, shouldn't it be 3 to the 4th instead of 3 to the 5th, or 3 over 5?
Yes, it should be. I'm sorry, I made a copy error there. Thanks, Chris. I was just making sure you're paying attention, that's all. Thanks, I appreciate it. Right, now we can collect like terms because we have a 5 to the n and a 5 to the n, okay? So we can rewrite the 2 as 8/4 if we wanted to. So, correct me if I'm wrong, guys, but I believe that if we combine 2 and -3/4, that would become 5/4 times 5 to the n plus 3/4. Okay. Because we could write 2 as 8/4. Okay. If I wanted to be even slicker than that, okay, couldn't I rewrite this as maybe 5 to the n plus 1 over 4 plus 3/4? Because notice in the numerator we have a 5, so that would be 5 to the first times 5 to the n. So we just have one more exponent of 5 that we're adding in there. So I think that might be the cleanest possible version that we could get of this in the most simplistic form. Okay? Although if you guys got to the last one, I certainly wouldn't knock off any points for that. Okay? But again, I want you guys to simplify it as much as possible, just so that way you guys can understand how that works. Okay? So this would be one of the most simplistic forms. In fact, I think it's the most simple form, because there's less stuff that you have to work with. Unfortunately, we have to make sure that we start the correct index with this. Okay? So.
Why wouldn't you just put the 5 to the n plus 1 plus 3 all over 4?
Oh yeah, we sure could do that. Okay? Another way we could write this.
I mean, if you wanted the
Yeah.
simplest.
Just one fraction. Yeah, we could do that. That's nice. It's 1 less 4 we have to write. So, sure. Okay. I like that one better. 1 less 4 I have to write. So I'm going to double box this one. So I don't have to erase my box already. Although if you got to either the previous or the second to last step, either of those, that's perfectly fine too. Okay, it's like how much lipstick can you put on the pig? All right, but we still have to make sure though that we start at the correct initial value in this. Okay, so we're going to say that n is an integer. Okay, and then if you guys recall, let's see, maybe not. But we said that the initial value has to be 2. So whatever number we plug in for n had better start at 2 with this. So guys, it's either going to be 0, 1, -1, something like that. So did I figure out which one?
0,
works?
0.
It's 0, isn't it, guys? Check out if you plug in 0. Okay? So n bigger than or equal to 0. If you guys plug in 0 here, 0 plus 1 is 1. 5 to the first is 5. 5 plus 3 is 8. 8/4 works out to be 2. Okay? So I just did it by inspection. Seems to work out pretty nicely. Okay? I don't want you guys to assume that the domain of the recursive sequence is the same as the domain for the non-recursive sequence, or the closed form of this. Okay? You can't make that assumption. In fact, we've already seen 2 instances today where that contradicts that already. Okay? So you can't just start at 1. Okay? You have to just go trial and error. Most of the time it's either going to be like -1, 0, 1, or 2. Something pretty basic. Okay? Alright, so these are the last couple problems I believe that are on assignment number 11. Okay, so any questions I can answer for you guys about being able to take the recursive types of sequences and being able to write them as closed forms? Okay. Alright, make sure you guys are definitely using this sheet. Okay, you gotta make sure that you have this. If you don't have it, either I got a couple up here or you guys can just get one offline. So that you guys
Can I ask you a question on
Yes, sir, please.
assignment 11?
Yeah, go ahead.
On assignment 11 number 8,
Okay.
okay, I did this thing, but the answer I was getting, I'll show you after the class. Actually.
Yeah, why don't you show me after class, because it might be like one of those things that's like you've got it down. And I don't want to say you're right or wrong with it.
Yeah, I mean, I think
But you will, right?
Oh, I will, oh, no, I'll tell you if you're right or wrong.
There you go.
At least what I think it is. I hope it is. Review. For the next month, right. I'm going, so, I'll talk to you. I'll talk to you later, okay? No, that's okay, no. So let me wait. That's okay. Right, let me wait till everyone gets a copy, hopefully extra. Thanks.
Oh, thank you. You're welcome. Thank you, sir.
We'll meet in the middle. Thanks, John. All right. Okay, everybody get a copy of the final worksheet, at least for the course. Okay, so the last topic we're going to take a look at in the course is graph theory, and graph theory is a fairly easy topic, okay? Most of you guys are going to find this to be extremely simplistic compared to some of the other things that we've done so far. Okay, now I want you guys to take the concept of a graph that you have and I want you to throw it away, okay? You guys think of a graph right now in Cartesian coordinates as the set of points that satisfies a one-to-one relationship, okay? Well, that's a function, okay? Guys, the graphs that we're going to be looking at are completely different than that. I want you guys to think of a graph almost like a telephone and a bunch of wires hooked up to a telephone, okay? Like when you guys were kids, you guys probably remember playing like the game where you tie like a string to 2 cups or maybe even 2 or 3 cups. That's what a graph really is in graph theory, okay? So when we talk about a graph, it's any geometric object comprised of 2 finite sets. There's a vertex set. Now a vertex is not a point that satisfies a relationship, okay? So it's not like a scatter plot or a parabola or a conic or anything like that, okay? And then there's something called an edge set, okay? That's basically going to be the set of all edges that exist in a graph G, okay? So let me give you guys just some examples of just some basic graphs, although you guys can see a graph down here. That's a graph, okay? Certainly not a function. And we probably couldn't be able to find some sort of equation to represent that, whether it be in Cartesian or cylindrical coordinates or whatever type of coordinate system. I don't think we'd be able to find a function to mirror that. Okay, and that's okay, we don't have to. All right, guys, take a look at this very, very simplistic graph. Okay, this is the dumbbell graph. Okay, this graph is the same as this graph. Okay? So these 2 graphs are exactly the same. There's no difference between those 2 graphs in graph theory. Okay? It would be the same as that graph. Okay? All 3 of these graphs are the same thing. It doesn't matter about the magnitude of the edge. Okay? It doesn't matter about the positioning of the vertex or the positioning of the edges, okay? In graph theory, it's all the same, okay? So, guys, does that fundamentally make sense, guys? It doesn't really matter how long your wire is. It just matters that the 2 cups are connected to one another, if you would.
vertex are those circles.
Correct. This is a vertex. So I could call this like V1, and I could call that V2. And this might be called edge 1, or E sub 1, okay? Generally in graph theory, like we like to denote vertices by V's and W's, and we like to identify edges by like E's and D's, if you would. Okay, so like this would be V1, V sub 2, E sub 1. This would be V sub 1, V sub 2, and then this mess that looks like a 2-year-old grabbed a crayon and tried to construct the Statue of Liberty. That's E sub 1. Okay? All right. By the way, we're going to learn this a little bit later in the course, but these 3 graphs are isomorphic, okay? Like you guys know what an isosceles triangle is, right? Guys, isosceles means 2 same, iso meaning same. This means same shape, isosceles, isomorphic, okay? Morph meaning shape. So these 3 graphs in graph theory are isomorphic to one another. We're going to take a look at that later in the course and how do we prove isomorphism. But for right now, I just want to make sure you guys understand. Okay, So this is really fundamental stuff. I'm just making sure everyone's on the same page. Some definitions for you guys. All right. Anytime I talk about an edge that's connected to a vertex, I say that it is incident upon that vertex. Okay? So in other words, E1 is incident upon V1. E1 is incident upon V2. Okay? So that's what incident means. Okay? Two edges are parallel if they have the same endpoints or the same starting and beginning and starting and ending vertices. So like if I was to do this and call this E sub 2, E sub 1 and E sub 2 would be parallel to one another, okay? Now you guys think of parallel in mathematics, meaning same slope, right? Same thing as like orthogonal, right? Or orthonormal, okay? By the way, what's the difference between orthogonal and orthonormal? Anybody know? Because they mean the same thing, right? They absolutely
Normal, yes, it has to be -1, right?
well, they both imply perpendicularity. One's a vector and one's a plane.
Gotcha.
So that's the only difference. So you guys have probably heard those terms before. One just means you're using a plane, a finite, I guess a finite plane. The other one's referencing a vector or an array that goes on forever. So yeah, so those terms are actually delegated very specifically for reasons. So regardless. All right, same thing with adjacent vertices. All right. Basically, when you talk about a loop, it's the same thing as a loop as you guys would think about in real life. You have a vertex, you have an edge, it begins and ends on the same vertex. Okay, nice and easy. Simple graph, no loops, no parallel edges. Okay, basically, there's almost like a one-to-one correspondence. Okay, you can only get from one vertex to another vertex by traversing an edge. Okay, a degree of a vertex basically is the number of edges that's incident upon that vertex. Okay, so it's really easy. If you can count the number of sticks that are going out of the vertex, that's the degree of it. Very easy. Degree of a graph is the sum of the degrees of the vertices. Okay, so you just add up all the vertices degrees. That's the vertex, or that's the graph's degree. All right. Something called the handshaking theorem or the handshaking lemma basically says that every graph must have an even degree. Okay, you can't have an odd degree of a graph. Well, you can, but you'll just be wrong. Okay. There's no way to have a correct graph to where the degree is off.
Can you, that is the sum of the degrees of, what is the sum of the degrees of vertices? What does that mean?
Where at? Right here?
Yeah, this is the sum of the degrees of the vertices in G. The degree of a graph, what is the degree of a graph?
Oh, degree of a graph is just the degree of all the vertices. So you take the sum of each of the vertices, that's the degree of the graph.
I mean, like how many vertices are there, units?
No, let's say like in this graph right here. This has degree 2, right? This V1 has degree 2, because there's 2.
Oh, okay, 2, okay.
This has degree 2.
2, okay.
So this graph has degree 4. 2 plus 2 is degree 4.
Gotcha.
Okay, that's all the degree of a graph is. So you find the degree of each of the edges, or each of the vertices, you add them up, that's the degree of the graph.
Gotcha.
Okay, nice and easy. Okay. Guys, any questions about any of these definitions before we go through and just talk about some of the definitions for these? Okay, very, very easy stuff.
So like in that diagram, that A, point A has 3 degrees, right? 1, 2, 3.
A actually is
4.
Yeah, so degree A, in fact, we're going to look at that later, that it does have a degree of 4. Other questions, guys? Okay, let's just go ahead, bowl through these questions. We'll get to stuff that's a little bit harder. Okay, so letter A, I asked you if the graph G is simple. Guys, why would that graph not be simple? It has some parallel edges, right? Can't we just name a pair of parallel edges? Maybe like what? E5, E4. We also see that E7 and E8 are parallel, okay? Because they both begin and end on the same vertex, okay? So, no. We could say E5, E4 are parallel. Okay, in parentheses, all of them put. So are E7, E8. Okay? Easy, right guys? We can all do that.
One more thing, when you're saying loop is the one that you drew, the third one, right?
No, sir. A loop is this.
Oh, okay.
So this is V1, this is E1. Okay? One edge, one vertex. Okay, that's a loop.
Like a ring.
Yep. All right. If I wanted to find the vertex of set, in other words, V of G, okay? V of G is the set of all vertices, okay? So it's a set, so we're gonna write it like a set notation. So all I have to do is just list out all the vertices, A, B, C, D, E. Okay, so that would be set A, B, C, D. Okay? Easy enough, right guys? We all know how to write the set of those, okay? If I was to ask you guys for E of G, okay, that's not a function, that's the edge set of graph G, okay? Wouldn't that be edge 1, edge 2, edge 3, edge 4, etc., all the way up to edge number 8, because there's 8 edges. So we could write this, oh, there's 9? Oh, there is an edge 9, if I could look at that. Sorry about that. Thank you. So that would be E sub 1, comma, E sub 2, comma, E sub 3. And then you guys could either write it out, or you could just do this, to where you denote the pattern. Okay? I don't care which way you guys do it. I highly doubt anyone's going to write out all 9 of those. Okay? As long as you establish a pattern and show that it works out, that's fine. Okay. Guys, any questions about a vertex set? Any questions about an edge set? Nice and easy, right guys? Okay. Name 2 parallel edges. C problem A, right guys? Didn't we already do that in part A? So no need to do it again. So C part A.
Can we do that on the exam?
Literally, it's right here, it says that these 2 are parallel edges.
Yeah, so
and
if
then I can
if
refer
there's a
back.
case like that on,
Sure.
or
Yeah,
even
I don't have
on
a
the
problem with
homework,
that.
like, can we just do that in
Oh, yeah,
C
sure.
or A?
Yeah, I didn't ask it on the homework of the exam.
Oh,
Sure,
okay.
you can do that. But no, I don't have a problem with that, it's clearly defined. Okay, if I wanted to ask you what the degree of vertex C is, okay, so deg C, or degree of C. Guys, what is the degree of vertex C? 5, right? There's 5 edges that are incident upon it, okay? So, degree of C would be